Can you explain how to determine which values should be chosen for m and p when factoring the polynomial of the form ax squared plus bx plus c? Now, if you'll notice, the lead coefficient here is 2, so we can't just find the factors of -1 that add up to -1. So we're going to factor this one a little bit differently. And what I'm talking about, m and p, is we're actually going to take the expression or the polynomial and we're going to rewrite it as ax squared plus mx plus px plus c. So we're going to be rewriting bx as mx plus px. In order to do this, we're going to take the first and last coefficients and multiply those two numbers together. So 2 times -1 is -2. So let's list the factors of -2, which would be -1 and +2, or +1 and -2. Now we're still going to apply the same principle, -1 times 2. If I added those two numbers together, would that give me a -1? No, but if I added +1 and -2 together, that would give me -1. So we're going to use 1 and -2 as the m and the p. So we're going to rewrite this expression here as 2n squared plus 1x minus 2x, or I'm sorry, n, minus 2n minus 1. So you'll notice it's the same problem, except now instead of -1n, I've rewritten that as 1n minus 2n. But if you add those two numbers together, you still get -1n. So now we have 4 terms, and since we have 4 terms, we can do factor by grouping. So let's start with the first 2 terms. The first 2 terms have a greatest common factor of n. So if I divide those first 2 terms by n, I'm left with 2n plus 1. The second 2 terms would have a greatest common factor of -1, because they're both negative. Then if we divide -2n by -1, we would be left with a positive 2n. If we divide -1 by -1, that would be a positive 1. So now we look at those 2 terms, and we see that they now have a greatest common factor of -2 or of 2n plus 1. So we're going to rewrite our final answer as 2n plus 1 times n minus 1. So our final answer for this polynomial will be 2n plus 1 times n minus 1.